Sorry, still not well. Nasty bug. I must have picked it up from college. Hope none of you catch it though. I shall bring myself in tomorrow, regardless. So please come Tuesday. And Nick, yes, you can bring your guitar and we will sing your song. Hopefully, well, we'll try. If you wish to, of course. Right. So today we're going to plough through parametric differentiation. There is a little calculator investigation here first. Getting used to pressing the buttons to look at parametric equations. So get your little mate out of its bag or your pocket or wherever you've been storing it. Hit the lid off. Hope the batteries are working. Press menu. Press graph. Clear every graph that's in there at the moment. Then press F3 for type of graph. F3 for parametric, and then Shift F3 V window. You can press F1 for initial and scroll down to check that you have to scroll down when you've got this V window up, that the T theta minimum is 0 and the maximum is 360. And let's have the pitch at 3.6. It just means it draws a dot every 3.6 degrees. Right. Have a go at the questions. Just plot these on your calculator and then answer the questions below. And I shall give you 10 minutes to do that. So you'll need to press pause and then have a go. Right, you've unpaused now. I'm not going to go over those because I want you to have a go yourself and be able to answer the questions. And it's pretty obvious if you've done them what the answers are. Okay, today we are dealing with differentiating parametric equations. We are going to be solving tangent and normal type questions and maybe practice an exam question or two. If you wish to have this sheet, there will be some in the room if you can find them, if you want to go and get one. Otherwise, just make a few notes or watch it and ask me for the sheet next time. But you'd still have to fill it in then, wouldn't you? That's tomorrow. But please do this before tomorrow, or I'm in a bit of trouble when I'm trying to teach you the next bit, perhaps. Suppose we want to find dy dx for a curve that has been defined parametrically. For example, that's parametrically. It's given me x, it's given me y with another parameter t in it. We can differentiate both of these equations with respect to t to give dx dt. Your pen working. Dx dt equals 2 and dy dt gives me 6t. Then if we use chain rule, hopefully we can see that if you were to do dy dt times and invert the other one, dt dx, you'd end up with dy dx, won't you, because the dt's cancel. So that is 6t times 1 over 2, which gives me 3t. So in general then, differentiate a pair of parametric equations, we can use the chain rule in the form. Ta-da. So another example here, define dy dx in terms of t for these, sorry, find dy dx in terms of t for the curve defined by the parametric equations, those things. So off we go, dx dt, differentiate that. Remember that goes to a minus, that's minus 2 sine 2t. And if we do dy dx, that gives me differentiate sine, just get cos t. So dy dx, oh, that should have been a t, my fault. Dy dx will be the y1 times 1 over that thing. Put them together, it might look neater. That's the answer, but you could take this further if you wanted, using the double angle formula for sine 2t, or remember sine 2a, it's on the wall somewhere, is 2 sine a cos a. So we can put in there then, that's the same as cos t over minus 2 lots of 2 sine t cos t. Cos t is dead, a bit like I feel. Right, so that's now minus, you could call it minus 1 over, 2 times 2 is not 2, it's 4 sine t. If you were very excited, you know that 1 over sine t is in fact cosec, don't we? So we could actually call that minus a quarter of cosec t. Done. This one, dy dx, find dx dt, dy dt, and do the magic. Pause if you need to, and the answer will come up when you unpause. Well, you got your algebra right. Try another. Please rewrite them as t plus t to the minus 2 before you try and differentiate it. One pause now. Here's the answer. You might not, you might have left it like that. When you times them up into here, you may have got this answer here. It just looks neater if you times everything by t to the 3 over t to the 3, which actually times it by 1, isn't it? And then you end up with that. It just looks neater. Not wrong. That's okay, but that's better. Right, what's next? So a curve is defined by a parametric equation, that thing. Find dy dx in terms of t, and hence find the coordinates of the points where the gradient of the curve is minus 1. Hence find the equation of the normal. So I've got to find the gradient and equal it to minus 1, it seems. and then we'll find the points that it is -1, won't we? Right, so let's get on. Divide x. So first of all, start with dx, dt. I'll use chain rule. 2 to the front, 3t plus 2 to the power 1 times the differential of the bracket, which is 3. So that gives me 6 bracket 3t plus 2. Got to do dy dt, that might be easier. Dy dt, that's just going to be 6t squared, isn't it? Right, okay, so dy dx, the y1 times by 1 over that thing. Good, the sixes will go. So that just gives me t squared over 3t plus 2. Right, we're told the gradient is -1. Can we find the value of t for which this occurs, do you think? Equal it to -1. Get those two up there, so I'll get t squared equals -3t minus 2. We'll end up with a quadratic, won't we? Put that in your machine. We'll spot the factors. Too hard to get. So therefore we've got t equals -1 or t equals -2. That's not what we really want, is it? So we can't be find the equation of the normal at that point, can we? We need this in terms of x, really. So okay, so we know it's the gradient of the curve is -1 when t is -1 and -2. So remembering that x on the last slide was 3t, y was, what was y? Y was 2t cubed plus 9, is it? I think it was. So that means that x for an t is 1x equals -3 plus 2 all squared, which is 1, and the y would be 2 times -1, which is -2 plus 9, which equals 7. And here when we've got x is t is 2, that would give me -6 plus 2 squared equals 16, and the y -2 cubed is -8. 2 times -8 is -16, then plus the 9 gives me -7. So the gradient is -1 at the 2 points 1, 7, and the point 16, -7, 7. So the equation of the normal at the point 17 will have a gradient of, that's the gradient of the curve at 17 is -1. So if the gradient of the curve is -1, the normal will have a gradient of, I can hear you shouting from your seat, 1, of course. And so it takes the form I minus y1 equals 1 lot of x minus x1, and leads us to the equation y equals x plus 6. Super. Right, there was a card sort. I'm very sorry you can't do it. But you can start the exercise from the book. That's the online book, the Cambridge Go book. You've all used it before. Have a look at those questions, just part A, part C on 1 and 2. questions 2, 4, 6 and 7, extension work 9 and 10 if you're brave. But all of us can just have a quick look at this exam question before you go back to do that work. Let's have a look. So here's an exam question. You can either pause it and have a go yourself, or if you're not confident, maybe you need to go through it. Pause now. Okay, unpaused. The diagram showed the curve C defined by the parametric equations. Those aligned cuts the curve C at points A and B. Find the coordinates of A and B. Show the Cartesian equation of the curve is that. So two things hit each other when they're equal to one another. So I need to sub into the line the Cartesian equations here. So substituting those into the line because they're equal to each other would give me 1 over t minus 4t plus 3 lots of the other thing, and it equals 12. Right, we can solve this for t. Grab the t's together. We've got 3 and we've got, so that's 4 of the 4 over t. We've got minus 4 and we've got plus 12t, so that's plus 8t, isn't it? That's 12 hidden quadratic here times everything by t, and then we'll get 4 plus 8t squared equals 12t, which leads us to the quadratic 8t squared minus 12t plus 4. Or you can cancel through by 4, etc. Or you can just pop it in your calculator at this point, and you'd end up with t equaling 1 over a half and t equaling 1. So they meet when t is a half and t is 1, but we want x and y coordinates for those points. So when t is a half, x will equal 1 over a half plus 4 lots of a half, which is 2. So if you're good at your mental maths, that's 2 plus 2, that's 4. And the y will be 1 over a half minus 4 halves, which is minus 2. So that'll be 2 take 2, which is 0. So point A is at 4, 0. When t was the other value that we found, which was 1, a bit easier now, x 1 over 1 plus, so we've got, I'll do that now, 1 over 1 is 1 plus 4 is 5, that's impressing you, I dare say, and the 1 over 1 minus 4 is negative 3. So point B must be at the point 5 minus 3. Super. So we've found the coordinates of the points of A and B. Part B of the question said show the Cartesian equation of the curve is x squared minus y squared equals 16. It's a show, it's not you have to derive. What we can do here is just sub in x and y and see if it gets us 16, the right hand side of that equation. If it does, super. If it doesn't, we all go home disappointed. So I'll start with the left hand side. x squared minus y squared. Sub in what we know. That's 1 over t plus 4t and all squared minus 1 over t minus 4, oops, mine pen won't work, minus, no, don't like me, oh help, 4t, oh dear, minus 4t all squared, right, messy, not messy, he'll be on the telly this afternoon, 1 over t squared plus 8 plus 16t squared minus 1 over t squared minus 8 plus 16t squared. Oh, good, things cancel out. Wonderful. Dead. Gone. Oh no, it's not gone because that's minus minus. I lied. Gone. That's minus minus. That's plus. So that makes 8 plus 8, which is 16. Well, which equals the right hand side. Bingo, we can go home happy. But there is one more exam question as a treat for us now. Here it is. Here's another question. So find the gradient of the curve at point t is 1. Where's t1? We can't see it on the picture. Oh, it is p here. P's here. P's here. This must be where t is 1. And the equation of the normal at the point p. Let's just deal with A first. So gradient dy dx. No way of doing it with parametric, so I'll turn over. Oh, no, sorry, I'm only messing. You pause the video, have a go, and then listen to the solution afterwards, or fast forward me to the end to check your answers correct. Pause the video now. Okay, if you wanted me to go gradient dx dt 4t dy dt 2t plus 2 dy dx then is 2t plus 2 over 4t, which cancel through by 2, so it's t plus 1 over 2t, and we're saying t is 1. So when t is 1, dy dx will be 2 over 2, which is 1. That means that the gradient of the normal must be minus 1. The gradient of the curve at the point is 1. I also know that when t is 1, what's x? That's above here, isn't it? So x will be 2 times 1 squared, which is 2, and y will be 1 squared plus 2, which is 3. So popping that into this thing, the equation of a line, we're going to have y minus 3 equals minus 1x minus 2. and then you can whisk that about as you please and get y equals minus x plus 5, I think. Lovely. Part B, well, that's part B, isn't it? Part C, what was part C? C, what did part C want us to do? It apparently wanted us to do the normal of the curve at point P cuts the curve again at point Q. Find the coordinates of Q. Oh, hope you had a think. So here we're trying to find when the equation of the normal equals the curve. So it's back to that idea where you make them equal to each other to find out when they cross, isn't it? So making them equal to each other means we just sub in our curve into the line. So the curve's in the parametric form. So I'll put those in to the line, and the line was y equals minus x plus 5. So if I sub those in, I'll get t squared plus 2t equals minus 2t squared plus 5. Make that into a quadratic, it'll be 3t squared plus 2t minus 5 equals 0. Use my calculator to find some answers for that. That should give me t equals either 1 or t equals, on the calculator, minus 5/3. Hopefully you found the same. If you wanted to bracket them, they would have looked like that. Right, now we've got the t value. So if t was 1, I get point P, which I've already had. No point finding point P again. So point Q must be on this other one. So finding the x and y coordinates, just stick them back into this original thing up here. That'll give me point Q. Oops, oh dear, there's some writing there, I'll ignore that. So when t is minus 5/3, my x will equal, won't be messy, it's fractions. Comes out to 50/9. And the y value would equal, even messier, do that on a machine, you'll get minus 5/9. And therefore your coordinates of Q are those two things. Okay, that's where I'll leave it there. There is some past paper questions, but I'll give you those tomorrow. I will be bringing myself in on Tuesday regardless, because I do feel like I'm getting better. I've got some tablets that are helping, but I'm just not quite right yet. Yeah, so I shall see you Tuesday. Please do the questions from the textbook, and yeah, enjoy your day, and I'll see you tomorrow. Bye bye.